Hello, we are going to be taking a look at Chapter P, Section 4, continued. We'll do pages 3, 4, and 5 today in this lesson. I do want to say that a lot of the stuff that we're doing in these sections is pretty easy if you're thinking about the sections as smaller entities by themselves, but keep in mind you will have a P1 through P4 quiz, and I've heard from some students that that quiz is pretty intense. So as long as you are pretty fluent with your knowledge of the concepts, you should be just fine. Okay, example 2. We're going to multiply the polynomials. You're going to have to use properties of exponents to do this. Now take a look at this. This is not FOIL. This is straight across multiplication. It's negative 3 multiplied with x to the 6th, multiplied with 4, multiplied with x to the 7th. So I'm going to multiply my numeric parts. Negative 3 multiplied with positive 4 is negative 12. And then, of course, I'm going to multiply x to the 6th with x to the 7th. Now, same base, operations multiplication, property of exponents says add those exponents. So I'm going to make this be x to the 6 plus 7 power, or x to the power of 13. And we are finished. Part B. This is distributive property twice. You're going to have to take the x and multiply it with each one of these. And then you take the 5 and multiply it with each one of those. It's a binomial being multiplied with a trinomial. So I know I like to cover this up, and I know I have to bump these up by 1 power of x. So that's going to be x to the power of 3. Subtract 5x to the power of 2. And add 25x. And now I'm going to just show the 5, and I'm going to multiply each one of these terms by the 5. So this now is plus 5x squared. Subtract 25x. And 5 times 25 is 125, so plus 125. Can't leave it like that because you have like terms to combine. So we go highest degree to lowest. It's x to the power of 3. I like to cross it off when I use it. I've got my second powers. Notice they're a pair of opposites, so they are going to sum to 0. My linears are also going to sum to 0, and what's left is my constant. Okay, not too bad. Next one, same type of problem where we are going to double distribute. So 2x with each one of these, and a negative 1 with each one of those. Watch your signs. So 2x times x squared. So I'm going to multiply each by 2 and then bump it up by power of x. So 2 times 1 is 2. That's going to be x to the power of 3. 4 times 2 is 8. It's negative. X to the power of 2. 3 times 2 is 6. They're both positive, and I need an x. Now I'm going to distribute a negative 1, so that becomes negative x squared plus 4x, and then subtract 3. And now again, just like the problem before it, I have to combine like terms. So I've got 2x to the power of 3. My linears, that's subtract 9x squared. I mean, not my linears, my quadratics, silly me. Here's my linear. 6 and 4 is 10. Don't forget about x to the power of 1. And then my constant, negative 3. Alright, not too bad. Just watch your signs. Use FOIL when multiplying two binomials. So remember, FOIL represents first, outer, inner, last. Or you can think of it as double distributive property again, this time with two terms across two terms. Alright, x times x, x to the power of 2. X times 2 plus 2x. Negative 1 times x, negative x. Negative 1 times 2, negative 2. The only like terms I will have here is these middles. So I've got x squared, positive 2 minus 1 is a positive 1, and minus 2. Pretty straightforward, pretty easy, just a little bit of a review to get you back into the algebra swing of things. Okay, FOIL again. 7 times 3, 21. X squared times x squared, x to the power of 4. 7 times 5, 35. It's negative. X to the power of 2. 3 times 2, 6. It's negative. X to the power of 2. 5 times 2, 10. It's positive. Combine your middle terms. 21 x to the power of 4. Right here, these guys going to give me negative 41x squared plus 10. Okay, pretty straightforward. If you have any questions, post it either in the homework discussion or ask a question in class or during one of your Google Meets if you are online learning. Folks, please remember that you have to watch these videos in their entirety. If you're only watching to 90%, then I can't give you full credit as a grade, points-wise, for the videos. Special products. Let A and B represent real numbers, variables, or algebraic expressions. So algebraic expression could be a quantity like x plus 5. So you're going to let A and B represent either a number, a variable, or an expression. If I am multiplying the sum and the difference of two terms, then the output is always going to be A squared subtract B squared. Remember, this was when we did the things with the radicals. This is multiplying by the conjugate. Okay, and the middle terms always would sum to 0. And that's what this says here. The middle terms add to 0. So if you recognize two binomials as being conjugates of one another, you don't even really have to write out those middle terms. Squaring a binomial. Well, I would like you to learn the shorter way of squaring a binomial. You're going to square the first term, square the last term. Okay, so the first would be A, the last would be B. Square the first, square the last. And then for your middle, it's first multiplied with last. Then you double it. It's going to be so much quicker for you to get through problems if you know how to square a binomial rather quickly. The model, the output model for this is A squared. Notice, if I take the first and I square it, I get an A squared. If I take the last term, B, and I square it, there's my B squared. For the middle, I just multiply them, first times second, and then to double means to multiply by 2. So it's plus 2 of these. This one here, the only thing different is the subtraction sign. You're still going to square the first, A squared. You're still going to square the last, B squared. You're still going to multiply first and last, AB, and double it, but this time you're going to have two negatives, so it's subtract 2AB. During a test or a quiz, I would have these models up for you. I just don't give you this part, okay? I don't give you, that part would be hidden. I would just give you this. So you should be able to look at this and say, oh, that's what you get when you multiply sum and difference of terms or those conjugates. This is how you square a binomial. I mean, look at the leader. It's being squared. Cubing a binomial. Well, the output is going to look like this. When it's plus here, it's going to be A to the power of 3 plus 3A squared B plus 3AB squared plus B cubed. Okay, so it's a formula, and we're going to apply it to these problems down below. I will say that we are going to go into Pascal's triangle and learn how to do binomial expansion. Binomial expansion meaning if you have a binomial A plus B to some power bigger than 2, you can use Pascal's triangle. You could use it for a squaring as well, but you know, if I have this to the power of 8, that's going to be huge. And so Pascal's triangle helps us with that nonsense. Okay, well, it's not really nonsense. It's just it helps us expedite the process. This here, you know, the a cubed, the 3a squared b, the 3ab squared, and the b cubed is all going to stay the same. But when it's subtraction in the middle, then these signs are going to alternate. So that's going to be negative, that's going to be positive, and that's going to be negative. Okay, so during this time, I have to do a Google Meet, so I'm going to do a part B video to finish up this page and the next page. I'll be right back.